You know the Hubble Space Telescope. It is the celebrity of the cosmos, the machine that showed us the pillars of creation. But did you know Hubble had a mother? Meet Dr. Nancy Grace Roman. She was NASA's first chief of astronomy. Long before it was cool, she fought for the idea that we needed to put telescopes in space. She is literally known as the mother of Hubble. And now, NASA is building a new flagship observatory named in her honor. It's called the Nancy Grace Roman Space Telescope, or just Roman. And if Hubble changed how we see the universe, Roman is going to change how we understand it. To understand Roman, you need to understand the problem with Hubble. Imagine looking at the Grand Canyon, but you're forced to view it through a drinking straw. That is Hubble. Incredible resolution, unbeatable detail, but it sees the universe through a pinhole. It captures a tiny, tiny slice of the sky at a time. Now, take away the straw and look through a giant panoramic window. That is Roman. Here are the specs. Roman has a primary mirror that is 2.4 meters wide, the exact same size as Hubble's. That means it sees with the exact same crystal clear sharpness. But its camera has a field of view that is 100 times larger. Hubble finds the needle in the haystack. Roman photographs the needle, the haystack, the barn, and the entire farm in a single shot. Same detail, massive slice. Unlike Hubble, Roman will never orbit Earth. There will be no astronaut servicing missions, no second chances. Roman is heading to a point in deep space known as L2, 1.5 million kilometers from Earth. It will operate alongside the James Webb Space Telescope. From L2, Roman gets a stable, cold environment and an uninterrupted view of the universe, without Earth blocking its vision every 90 minutes. Launch is currently targeted for late 2026 to May 2027. And once it arrives, Roman begins its real work. Mission 1: Dark Energy. The greatest unsolved problem in modern cosmology. We know the universe is expanding, but more disturbingly, that expansion is accelerating. Something invisible is pushing galaxies apart faster over time. We call it dark energy, which is science's way of saying, we don't know what this is. Roman's panoramic vision allows it to map millions of galaxies across cosmic time. By measuring how space itself has stretched, Roman will test whether dark energy is a real force or a sign that our understanding of gravity is incomplete. In other words, Roman may tell us whether the laws of physics need rewriting. Mission 2: The Exoplanet Census. Roman will use a technique called microlensing. It locks onto the crowded core of the Milky Way, watching thousands of stars simultaneously. When a planet passes in front of a distant star, its gravity briefly magnifies the starlight. This method can detect planets other telescopes miss, including rogue planets, worlds with no sun, no orbit, drifting alone through interstellar space. Roman is expected to discover thousands of new exoplanets, revealing just how common planets truly are in our galaxy. Mission 3 is Roman's most experimental technology, the Coronagraph. Trying to image a planet next to a star is like photographing a firefly beside a searchlight. Roman's coronagraph physically blocks starlight inside the telescope, a precise system of masks and mirrors. This will allow Roman to directly image large exoplanets. Not Earth-like worlds, not yet. But this mission is a proof of concept. If it works, future telescopes will use this technology to image planets like our own. Roman is building the road, not driving to the destination. Hubble showed us the beauty of the universe. James Webb is showing us its origins. Roman will show us its structure, its patterns, its scale. Panoramic skies, dark energy, rogue worlds, and technology that points toward Earth-like planets. The Roman Space Telescope launches soon, and when it does, our understanding of the universe may never be the same.